So the first thing that I want to talk about is the actual problem. And like I said before, the pathology field is shrinking, and the number of cases that pathologists deal with every day are climbing day by day. And about 30% of practicing pathologists in the US are expected to retire by 2030. And these projections show that the supply is dropping around 7%, while the demand for pathology is increasing by 16% by 2037. And around 60% of pathologists already report feeling overworked with caseloads above 100 cases a day. So one pathologist does on average 100 cases a day in a span of 9 hours. And the number of pathologists per 100,000 people is expected to fall from 5.7 to 3.7 over the same amount of time. And these numbers come from official sources like the AAMC, HRSA, and the workforce surveys from the College of American Pathologists. And so the first thing that I really want to talk about is what my actual product does. So the name of the website is called PathologyAI, and this is the exact workflow in the website. So the first thing that happens is that the reviewer is going to upload a picture, for example, a PNG or a JPEG or even a TIFF format, and then my system will accurately first detect the image for its image quality, seeing which parts can be accurately used for the model. It will then check for the tissue coverage, the focus, the exposure, and the stain variation, because these slight things can negatively affect the score. Especially with blurry images. I've trained my models to look for blurry images and automatically reject them because they can give false readings. And then the next thing that it does is that it tasks specific models, or what you can do is you can run all the models simultaneously, and then it will look for overlapping tissue patches across the entire image. And there is specific surface evidence, for example, heat maps, overlays, all the stuff that the user needs to see where is the cancer, and where can the human review this. And then finally, the human will then report the final investigation, because AI models are never too accurate. The human will have to review it at the end. And so I want to talk about why I actually built this. And so pathology teams are dealing with increasing volumes every day, and their workload is getting more and more. But there's no real solution to combat this, especially because the technology for this is very demanding, and there's not much outreach on this topic. And so most of people either overstate what the model knows, or they just dump raw probabilities and lie in models. And so that's really what I've tried to overcome. And the next thing I want to show before I continue my presentation is the actual website itself, because then I will be able to demonstrate specifically the models themselves. That's what I'm going to do now. So when you reload the page, this is the landing page of the website. This will show you everything about the website. So we have pathology AI, as well as how it works, all the models, everything that it looks for, everything that the website really has, especially Q&As, because websites really need those these days. And then when I sign in, this is with Google OAuth. You can also do it with their email and password as well, but I'm going to choose OAuth for this one. So I'm going to sign in. And this is the first page that you see. So in this page, you're going to see multiple things. So the first thing that you can see are your previous cases that you've done. So for example, I've done this one, which had a 99% detection for cancer, as well as 74 and 60. And you can click on them to see, what does this have, what picture was it? And so the next thing that you can see over here is that de-identified only. The reason for this is that you really don't want to waste your time on putting an image that's already dealt with, right? Because that's really a waste. And one thing that I quickly want to mention is that all of these models run locally on the computer. I'm using something that's called ONNX, and that's letting the models run locally on the computer, just because free sources like Hugging Face, those can be really slow, and they often cost a lot. So that's why I chose to do it locally. So here it says drop a de-identified pathology image, or click to browse. When I click this, it's gonna look at my computer. So I already have these preloaded, and let's say I choose this one. So then it loads the image. And the next thing that you can see is what this image is actually for. Now, this was for lymph node. So I would choose lymph node, and there's auto route, meaning it would go through all the models locally, or you can choose a specific model. And since this is specifically lymph node, and I'm 100% sure it's not any of these, I'm going to run lymph node metastasis, which is powered by PCAM. And a quick note is that I have trained the PCAM one and the LC25000 myself. These were trained on my computer, and and for the PCAM, it has I think it was 89% accuracy rate, and the LC one had around 95 accuracy percent rate, and that was with 300,000 images each on both model. And so for this one, I'm gonna run lymph node, and if I click run selected model, it's gonna load it onto my device. It's gonna start running on my browser. It takes a bit. And here we see, this is the original model. So this is the original image that you saw. And here's the evidence overlay. So the evidence overlay just shows where the cancerous parts are. And it also differentiates between what is tissue and where's the actual cancer. So this white part is actually tissue. This has no cancer, and it highlighted everything that has cancer. So it drew apart. And the way my model works is that first it does a full image pass, and then it breaks the image down into multiple parts. So you can see all these little squares that I broke it down to, and these are the most concentrated parts of cancer that it thoroughly looked through. And below it, we can see all the statistics that the model had. For example, this one has a 99% signal. Obviously, AI cannot have 100% accuracy, as that's not possible. There will always be times where AI does make mistakes, and so that's really what my model demonstrates, is that's 99%, as well as the mean signal, meaning that it has a 61% rate across all tissue because these parts were not counted, as well as a 91% of the tissue did have strong likelihoods of cancer, as well as I broke it down to 253 parts of the picture, and it sampled those, as well as 177 of them were detected as cancer. The threshold value basically means that 71% was 100% verified as cancer, and then the 30% was uncertain, or it was below 95%, as well as the total uncertainty rate was 25% across those samples. And then the focus on this image was 100%. As you can see, the original, it was very clear, as well as a stain variation. As you can see, there is some yellow tinting. It's not perfectly white, which means that it did have stain variation, and it found that. As well as that it did find five connected new regions, and so that just basically means that where there was 5 regions that all had cancer together, and that was 100% certainty rate. And below we can see a quick way for a non-expert to read this, because this website is made for people who are not experienced with cancer, or even professionals who know how to deal with cancer. This makes it very easy for people who are not so sure with cancer, and how to read this information, as well as you can see some statistics of the model of what it used. So we can see that the AUROC was 0.891. Like I mentioned, it was 89%, so it's 89.1%, as well as the AURPRC, which is 0.897%, as well as the sensitivity of the model, which is 84%, and the operating threshold, which is 26%. Here we can see the same stats as above, but they're more below, just so the user sees more accurate example. And then we have where the human can actually review this. So here the human reviewer can actually put the confidence of the model. It can also say, is it coordinated, discordant, or intermittent? And then they can also write a quick thing about this model was accurate with the name and whatever, and they can save it. And then the user can actually export this data across all these model types. So example, they can have that CSV, TSV, JSON, HTML, PDF, PNG. They can have all of this with all the data included. And then they can save it, and it's right here. And so now the user can access this information once again. And now I quickly want to explain the architecture of the website. Oh, sorry. So the first thing that I want to show is all the models that I've used. So PCAM, which I trained locally on my computer, as I said before, it had 89.1% AURC with the 83.5% sensitivity, as well as the LCD model had a 99.5% AURC with the 95.5 policy accurate, as well as some online models that I found online. For example, Cather 100K, ISIC swine, Hovernet, and the Uni 2 model. These all have their accuracies as well, like the 96.4% by Cather, 91.2% by ICIC, but the HoverNet and the Uni2 do not have published accuracy. Rather, they have their own other stats. And if I continue with this, you can see the true architecture of my website. So I've broken down this website into a front end, a back end, and also my API with the Onyx runtime web. So my front end is on React and is being hosted on Versal, as well as that I have my back end, which is running on Supabase, and that has all my client information. All the accounts that are made go directly to Supabase via my API, which I'm using Fast API, which is a Python-based API, and so that's in between both of these. And so I really wanted to emphasize user privacy and also user security, and so that's why I implemented an API with the backend. Is because because low security websites often just have front end or weak backends, and so I really want to emphasize that by putting an API and Supabase backend, as well as my Onyx runtime web, which basically makes it so that the user pictures and the models are run locally. That way they can save on hosting, and also the fact that they'll be much faster depending on the computer. And this is research only by design. So meaning that my website can never claim that it's 100% cancer detection accurate, because that does not exist. That can really not happen without a human reviewer. So these models just help pathologists speed up the work, because they quickly tell you, is it cancer, is it not cancer, and also the detailed regions of the cancer themselves. And so that really makes it easier for pathologists, and the workload will be decreased. And some few things that I want to work on this in the future. The first thing would be whole slide support, which means that I can upload multiple images at once. I can run multiple runtimes at once. I can do all this. And for this, I would need to host my models somewhere else, because most computers will not be able to handle such heavy processing. The second thing is the external validation. Cather 100K and IC are very heavy, and so they need to be held out in external validation, just because that's the more proper thing to do. It will also make the website feel more better, because it's going to be more accurate, as well as that there should be an automated test suite. And so they should really focus on the models themselves, and also train the models better. And also I can see what models are weak right now, and how they can improve, as well as that there should be some way to link this to specimen match defaults. So you can run more scopes. For example, I ran the lymph-node scope. This is only meant for humans, but it could also be for animals as well. And that's something that I really want to scope out to. But for that, I would need to train more models, as there's not really many models to choose from online. And that was the end of my slideshow. Do you guys have any questions?
Yeah, Vasu. I think this is a really good presentation. The fact that you included so many numbers really makes the person who's sitting in front, right, very confident about your project that you have built. Okay. And the explanation was also pretty simple, that I was able to understand, okay, this was the product, why you're trying to build it and all that. I would like to know, where did you get the motivation to come up with this project, this idea itself? Or was it just something that just randomly came up in the discussions like that?
So the motivation for this is actually I'm trying to study biomedical engineering in the future. And so the one thing that I learned was that pathology is a dying field in these days, and that there should really be some sort of technology to help with this. And that's really what inspired me to do this, is that I found by research myself that pathology is something that not many people are doing these days, and that there should be some sort of invention, or some sort of thing that can help with this field. And so that's that's really the real motivation that I got. And especially when I found that out, I started researching extensively on how does it even work, what do pathologists do in the in general, what variables they use. And then after I learned that, I became very interested in this, because it's a very interesting field, but but the field itself is not being popular these days because of the workloads that people are experiencing.
Uh, okay. One more thing that I noticed that you had just broken that bigger image into very smaller chunks. Okay, that was something really pretty cool about this demonstration and all. And like, on an average, like how many reports can be done using your tool, like in the current MVP stage, and later on, maybe like 6 to 7 months right from now, like how many images do you feel can be processed on a day-to-day basis?
Like all at once, or just like a user doing a
Like
lot of images through the day.
just like in a day, like in span of like 8 to 9 hours, like in a
Oh,
whole working session. Yeah.
so my models are pretty fast. Like depending on the computer. So currently I'm on a MacBook, right? And I have 24 gigs of RAM. I usually get one model, like running one model takes about 5 seconds to the latest. And there's really no limit on my website. It's because everything's being stored, right? So there's no limit. You can run as how many as you want. It all depends on your computer. Because this is still in development, I am thinking about hosting, all of this to like GPUs because a lot of computers might not be able to support this. But if you are a pathologist, you are given a lot of powerful tools like powerful computers. You are given MacBooks and laptops, right? And so that's really why I chose to do it in the early stages to run it locally, is because most pathologists are already given all these computers. But in the future, I do want to make it so that all these models are hosted somewhere, and then it's not running on computer. But to your question, you can run however many your computer allows, and in the future, it's gonna be the same thing. But instead of a computer running it, it's gonna be a GPU of some sort.
Okay, got it. Yeah, one more thing, like, currently, like, what is your baseline? Like, how are you able to understand that, okay, the results that I'm producing, is it like a 99% or a 98%? Like, this, like, what's the accuracy currently right now, and how are you trying to increase that in like in future?
Yes. So my accuracy, as you see right here, the two models I trained myself, they had a 89.1% and not and a 99.5%. And the way so currently I know this is because the models themselves were trained on images, right? And they're trained through images, and I also including variables. So I used 300,000 pictures for each model, right? And so through those images, it was constantly looking for specific types, and already used an encoder, which was a Uni2H encoder for all of these, and that's because the Uni2H is already trained for this. It's been used for like I think it's been used popularly for the last 5 years, and it keeps getting updated. But the encoder itself is really good for detecting these, and so that's what I trained it off of. And so that's why my accuracy is 89.1 and 99.5. And in the future, I'm going to give it more training data and more samples to train off of, and that's how I'm going to improve my accuracy. And
Oh,
also, I'm going to give it a wide variety of
no,
sources.
got it. Yeah, so yeah, Vasu, that's it from the technical side. See, we have another panelist on the call, so he'll be joining after I leave. So he'll be interacting with you and your parent. Uh, so yeah, that's it. Yeah,
Okay. Thank you.
yeah. Thank you. Bye.
Bye bye. Have a good day.
Right. Hi, Vasu. How are you?
Hello. I'm good. How are you?
Yeah, I'm